Our next set of fantastic speakers are joining us from Devon. Gunasekaran is a security consultant and a DevSecOps lead with Devon. Maran takes joy in staying abreast with the security advancements, contributing to open source community with the most recent contributions to OWASP projects, evangelizing security among DevOps professionals as an ambassador for the DevOps Institute. He is joined by Mohd Siyam, who is a senior security architect at Devon. He's passionate about software security, cloud security, and enjoys sharing his knowledge through various trainings. He works with various Agile and Scrum teams in helping them deliver secure software sustainably at speed and scale. Joining us today, they're both going to give us their valuable insights on assuring compliance in DevSecOps. Ladies and gentlemen, let's give a big shout out as we now invite on the e-stage Gunasekaran and Mohd Siyam. Over to you guys.
Hey, welcome everybody to our talk about assuring compliance in DevSecOps. My name is Gunasekaran and I am my colleague Mohd Siyam. We both are chief consultants working at Devon. About ourselves, just a little bit before we get started, we are certified ethical hackers, we both are, and also EC Council certified security analysts. We got a couple of certifications on the Azure and AWS front as well. Working at an agile company such as Devon for a very long time also has ingrained the shift left and agile mindset within us from the very beginning. So naturally, we had to pursue some of the scrum.org certifications to master the art of software development using Scrum. And our primary trade happened to be security. So we're associated with DevOps Institute as certified trainers and ambassadors for DevSecOps courses. We're also contributors to the Open Web Application Securities Project's flagship project, ZAttack Proxy. And we're also certified Microsoft trainers to certify on most of the security certifications at Microsoft. And from a compliance perspective, I'm a lead certified auditor for ISO 27001, where we're going to talk a lot about ISO 27001 certifications and compliance today. We've also authored some courses at Pluralsight. One of them being writing custom scripts for OWASP ZAttack Proxy, so feel free to check that out at our own time. And in short, I go by the name Maran, and Mohd Siyam, in short, goes by the name Siyam. So what are we going to cover today?
Hi, thanks Maran for the quick introduction. So this is the agenda for today. So we are going to talk about some of the security challenges faced by organizations. Based on our experience with our customer, we are going to talk about some of the pain points that they had when it comes to security. Then we are going to talk about classifying compliance requirements. When we have a different compliance requirements in organization, then how do you deal with that? Then we are also going to speak about how DevOps complements compliance, how DevOps is not a barrier for compliance. Then we are also going to talk about compliance from a dev and ops viewpoint. Also, we are going to talk about toolset and also some of the practices that can be taken care when it comes to compliance. And we also have a couple of demonstrations that we are going to show you today, right?
Okay, so when we go on consulting for DevOps or DevSecOps, we hear a lot of challenges that organizations face. Some of them I'm going to present you here, which are most related to compliance and security. The most oftentimes what we hear is some of our customers say, we don't want to fail our monthly releases because we did not meet a compliance or a security requirement. And the other challenge that we often hear about is security is still a stopper for our releases, and security and compliance does impede our velocity and time to market. And here's another interesting one. Sometimes we often hear, I'd pay whatever you ask for, when you solve our bureaucratic policies and our internal departmental politics. So some of them are security-related challenges, and especially the departmental politics one. Every organization, big or small, has it at some size or the other. So running insecure systems from insecure baselines, right? We want to tell you a story before we begin. In June 2017, exactly 3 years ago, WannaCry, the most notorious ransomware in this decade, took over Honda's production plant offline. And the reason they did that is Honda wanted to construct a new production line, hence the IT engineers used an existing baseline image to build the operating systems and the other software required to run that new production line. And oftentimes, organizations have these baselines, sometimes referred to as golden images, which have these pre-tested and pre-qualified, security certified, performance certified images that have all the dependencies that are required to run a certain system. And when those systems, those baseline images aren't constantly updated to tackle the latest threats, then you might be in a situation just like Honda was 3 years ago. Well, if you fast forward now, today at the present day, June 2020, there's another tweet from Honda Automobile Customer Care. What this happens to be a targeted attack again on Honda, because as you see on the right of the screenshot, a network traffic capture reveals that the attack only starts encrypting the file systems when the domain name matches mds.honda.com. This is again another ransomware attack because the company apparently had some remote desktop computers due to the work from home situation. Remote desktop computers, there were some of them publicly available. Detailed investigation is still under progress, but there's many instances of remote desktop computers being open to the intranet and companies building insecure systems from insecure baselines. So we're going to talk about some of the techniques from an infrastructure as code perspective today that is going to help us navigate through these vulnerabilities and be reasonably secure at the current test of times. And organizations often have baselines. The example controls that you see on the screen right here, some of them can be automated and some of them can't be automated. If you look at 4.1.1, security best practices, example OWASP top 10 must be followed. This is an example from an information security management system that we were working with a partner with, asked us to be compliant against. And obviously it's an information security management standard, so there's going to be a lot of should, and most of the times there's going to be a lot of musts. So how are we going to translate the organizational baseline compliance requirements to something that we can edibly consume, bit-sized, and translate that to compliance requirements? Before we do that, let's take a step back and explore the development organization security responsibilities and the operational organization security responsibilities, because these are two different worlds. At least they used to be two different worlds, and with the recent advent of DevOps has already crossed the chasm, so we're talking about DevOps now. But because we're trying to create this new breed of DevSecOps, we're evolving faster, and it's essential to understand the differences, at least in terms of responsibilities from a development or / engineering shop versus an IT or an operational shop. So IT is often concerned about patch management when it comes to security, network segregation, system level security, software, hardware, asset management, wires, firewalls, and all of these things fall under network security. Well, this is only a subset of things, whereas the development shop is often worried about defensive programming. How are we going to keep our code base up to date with the latest threats? How are we going to deal with software level vulnerabilities and ensure that our code that we push to production is not insecure in any way and not going to be attacked? So at some point in time, developers and operations need to work together. And in the current fashion of DevOps, some of these responsibilities overlap to a greater extent, whether you have a single DevOps team or you have representatives from development and operations to form a DevOps team, or perhaps there's a security champion interfacing between your development and operations. These practices still apply if you want to be compliant in the fashions of DevSecOps. And systems can be hardened in many ways. We're talking about hardening because we want to be secure. And there's a great example from Center for Internet Security. There's also the Defense Information Systems Agency's standards that tell you how you can harden your systems. These are what we like to call these as low-level technical standards, because they aren't very high level. They go down to the minute details of Windows, Linux, Dockers, containers, virtual machines, and then they tell you this is the exact registry setting, this is the exact permission that you need to have on a file share. And we want to harden these systems because we're constantly under attack. What we would like to show you here is an example of a real-world threat map from Kaspersky. And if you pick a country there, we're going to see the different kind of attacks that are happening as we speak right now, real time, with respect to Kaspersky's deployment of their security systems. So Kaspersky has their security systems deployed worldwide, and they take that data, represent it in the most consumable and user experience, most greater user experience as possible. So systems are often under attack. Your computer, my computer might be under attack right now, and it is our security systems that are keeping these threats at bay. And that's why we want to keep our systems secure, and we want to keep our security baselines secure. And yet we continuously deliver business value. Developers push code to production multiple times a day. What kind of security does that code go through when it has to be pushed to production, or some of the things that we should consider? If we identify a vulnerability using our continuous integration pipelines, how much time does it take to fix that vulnerability before we push that code to production? Or according to our risk management, how are we going to tackle that vulnerability and fix it after X number of days? Are we willing to go forward with that vulnerability still going to production?
Yeah. If you look at the attacks on insecure systems, attacks can happen because of a variety of reasons. Some of them are because of unpatched system, which can lead to any kind of malware attacks. Or in the current trend, a ransomware attack in the form of COVID-19 or work from home phishing campaigns. There is a new type of attack going on as we speak, dubbed as a meow attack, where an attacker identified insecure databases, rewrite the database contents to meow, just like a cat. Attacks can also happen because we have third-party software or library that we trusted. But just like our own code, and the third-party library started installing malware and attacked users, or the third-party library abused the users' computers and web servers to mine cryptocurrencies. According to Verizon Data Breach Investigation Report a couple of years ago, it mentioned that only 14 of 20,000 software flaws were zero-day attacks. So that means every other attack had a different reason, such as the ones listed above.
And when we're talking about compliance, we're talking about legislation sometimes, legislations that come from the state or governmental bodies, such as the Sarbanes-Oxley Act or the Healthcare Information Portability and Accountability Act in the United States. Or sometimes it can be regulatory as well, such as the GDPR in the European Union, or NIST from the National Institute of Standards and Technology, or it can be a contractual obligation, such as ISO 27001, or a payment card industry data security standards that you have to comply with. Sometimes contractual obligations might include Center for Internet Security benchmarks as well. So as a typical enterprise, on any given day, you're dealing with more than one compliance requirement. And when you're dealing with more than one compliance requirement, you're going to have some kind of compliance mapping or a compliance matrix, such as the one that you see on the screen. If we zoom it in a little bit, the Center for Internet Security publishes top 20 security controls, and number 1 is inventory of authorized and unauthorized devices. With ISO 27001 and ISO 27002, that control can be mapped under A, 8.1.1, 9.1.2, 13.1.1, and so on. And a PCI DSS standard, the inventory of authorized and unauthorized devices, can be mapped under 1.6 and 2.6 and so on. So you're going to have to map your security controls so that it suffices multiple compliance requirements. Otherwise, there's going to be a lot of chaos. And normally organizations do that in their authorization matrix or statement of applicability or risk registers of some sort in a vulnerability management program. Here's an example of an ISO 27001 compliance requirement. A9.1.2 talks about access to networks and services, and then mentions users shall only be provided with access to their network and services that they're specifically authorized to use. Well, that's a great control. How are we going to translate that into a technical requirement and a technical control and make sure that control is audited and implemented and verified at all times? And 8.12.5.1 talks about software installation on operational systems. Now, we need to have procedures to control the implementation of software on operational systems. So that's an example from ISO 27001. And when we talk about inventory of software, 2.4, maintain an inventory of system components that are in scope for PCI DSS. That's an excerpt from PCI DSS, which also talks about keeping an inventory of authorized and unauthorized devices, and also goes into great detail in discussing what are the audit mechanisms that you can use in order to ensure that that control is implemented and verified on a periodic basis. Now, these are great compliance requirements. They're at a very high level. If you want to translate that to technical requirements, and that's where we have the Center for Internet Security, or the DSSTIC standards. The example that you see in front of your screen is a Center for Internet Security benchmark for a CentOS Linux operating system, which says if you're going to have an inventory of services that should not be running and a set of services that should be running, and from a system hardening perspective, Telnet should not be installed, TFTP should not be installed, rsync should not be installed, and there's so many other controls. This is a 300-page PDF approximately, which goes into great detail to document the exact technical requirements that you need to comply with if you want to stay compliant with those high-level ISO and the PCI DSS controls. And when we talk about security domains in the new world of DevOps, there's network, infrastructure, and data, often called as operational security or acronymed as AppSec and ITSec. And application code is called as software security, DevSec and AppSec. The way compliance is going to be implemented in these two domains are going to be very different. We're going to have a lot of overlap in some places because there's DevOps and there's DevSecOps. But speaking semantically, a testing tool that you're going to use for testing your infrastructure is going to be way different from a testing tool that you're going to use for testing your application. It's as simple as that, and hence their compliance requirements also vary a little bit.
Here is a high-level requirement which talks about educating the developers to adhere to PCI DSS requirements, like training developers frequently, at least once a year. They don't talk about training DevOps team or the Ops team here. However, at the current state of DevOps affairs, it is required that we train anyone that is involved in software development and delivery. There is also a requirement about developing application based on secure coding guidelines. The PCI DSS, compared to many other standards, goes in great detail to explain what is the secure coding guidelines are, and also leave a message that we should follow industry security standard guidelines in the application security landscape, such as OWASP Top 10, CWE Top 25, CERT security guidelines, etc. Some of the application security controls as prescribed by PCI DSS are 6.5.1, like application should not have injection flaws, application should validate the input, application should use parameterized query, and 6.5.2, such as application should not have buffer overflow and hence should validate buffer boundaries, and 6.5.7, application should not have cross-site scripting. Like we mentioned before, PCI DSS is one such of the few standards that goes to great length to detail in application security requirements.
And the example that you see on the screen from a very long time, application security tooling such as SAST and DAST supported out-of-the-box compliance requirements from a very long time. So here's an example from one such security tool, SAST tool, check marks that says, after scanning a code base, here's the vulnerabilities that I've found, and then here's how they are categorized under the PCI DSS, and we can use this as an artifact during our audits with PCI DSS to improve our security systems ourselves. But if the security tooling from an application space had support for compliance requirements from a very long time, what does that happen when we talk about DevSecOps? How does that work? How does compliance requirements work when we talk about DevSecOps?
In DevSecOps environment, when you are thinking shift left, you have to think about security even before the code is written. Let's take an example of building a feature that cuts across your authorization, API, and database modules. From a security perspective, we have to think about what is my session timeout? Is it 5 minutes or 30 minutes according to industry requirement? Authorization token security. We need to also think about security of data at rest or data in transit, and also threats such as SQL injection. If you compare this to PCI DSS requirement, we are talking about compliance here. One of the ways we have seen development and DevOps team capture requirement is as part of the user stories and acceptance criteria during their sprint planning or PI planning sessions in scaled agile. Developer training is essential. Some of the organizations that we have worked with have partnered with training institutions to deliver application security way back in 2012. The trend that we are witnessing these days is the amount of effort put in training the developers and DevOps in security has exponentially increased. We work with some of the banks in Europe, which we have delivered the customer training content specifically developed for security in C, C++, Java, and various other programming languages and frameworks. At the end of the day, it is if the developers don't write secure code, then sustaining security efforts in Dev or DevSecOps becomes a challenge. Also, the adoption of security tooling such as checkmarks, Fortify, and contrast security in the earlier stages of software development lifecycle has grown organically over time. Now, application security tooling with compliance requirements are more tuned to target developers and their environment, build environment such as IDEs and build system. Monitor is also an integral part of application security landscape, and hence OWASP Top 10 2017 decided to introduce top 10 titles like insufficient logging and monitoring.
So the example that you see on the screen is a policy of code. This is what we would refer to as the compliance stuff in a DevSecOps fashion. One such organization that we were working with decided to take all those compliance requirements, very basic compliance requirements from an application security perspective for web applications, and decided to notify the build server with warning messages as opposed to fail. They just wanted to warn because they wanted the tool to have a learning time and then tune the alerts so they can be very sure when they want to fail a build. And traditionally, when security tooling had all of these compliance requirements out of the box, the way it's going to work in DevSecOps is more and more towards the shift-left approaches of using these plugins in the IDE to support those compliance requirements, or using examples such as policy as code to mention whenever a security test fails according to a compliance requirement, then we want that build not to go to production. So that's the new trend we're witnessing there. It can for technical security requirements, but here's an example of an AppSec control in real world. This is a document that a partner provided us to be compliant with ISO, to be compliant with our contractual obligations. If you look at 4.1.2, they say debugging must be disabled prior to the application being released. Well, that is something that is very easy to be checked using a configuration file, whether debug is enabled or not. We can automate that too, certainly to a large extent. But if you look at 4.1.3, functional testing must include error handling. Maybe we could write some automation there to identify 404 errors or 500 internal errors during functional automation. But 4.1.4, the development team must document all decisions. That in no way can be automated. When you're in a sprint planning session and you decide that you want to use 2048 bit size instead of 4096 bit size for an asymmetric algorithm such as RSA, and here's the n number of reasons why you decided to do so, then that is something that you want to put in your Confluence or SharePoint or your internal wiki pages according to the standard. But that isn't something that can't be automated. That is something that can only be implemented, audited, and verified manually, at least at this point in time. Well, there's ways to explore automation there, but that is certainly not one of the first candidates that you should be picking for automation. You got to pick the easy wins first to get some momentum going in your teams. And with non-granular or high-level security compliance controls, they can't be automated, hence they're not faster, and they require manual checklists, hence they're not repeatable, but they're yet required by many regulations. You can't automate them all just anytime you want. The focus really is to think about, take all of these compliance requirements and then figure out what can be automated and what can't be. And for the things that can't be automated, like Siyam spoke about, include those requirements way back into your sprint planning or technical design sessions and involve your compliance folks early in the software development lifecycle to see how they can be of help and not really impede your production releases or the velocity at which you ship your software. When it comes to compliance as code, it's exactly the opposite of these non-granular technical requirements. Compliance as code, because it's code, it's automatable, hence it is faster. And because it is coded, it's also repeatable. You can run them anytime you want. And some of these frameworks or tools that support compliance as code, they provide you with a readable format in certain programming languages, which invites conversations with developers and which invites conversations with your operations and IT auditors. For example, the last time we were in an ISO audit were a couple of days ago, and auditors, or even as a certified auditor, we look at a requirement such as 8.1.1, and then we see how you have a technical requirement documented for it and whether you have necessary evidences to support that you are complying with that security requirements. Sometimes compliance is about law as well. But readable documentation, readable code invites conversations, and we're going to see that how. And it also clarifies the granular security checks. To complement compliance as code, there's also this emerging trend for the past couple of years, so almost 6-7 years, about continuous compliance. So just similar to continuous delivery and continuous everything, there's also continuous compliance. And there's so much of tooling within this space that it actually becomes a collaboration challenge between how are we going to communicate with these tools, how are we going to radiate the information from these tools to the right stakeholders. Qualys, one of the top security companies, have a continuous security platform that also supports continuous compliance. Tenable, Nessus, one of the leaders in the market, again, support continuous compliance. Azure Security Center in the cloud, we're going to see an example of that. And then AWS Security Hub, all of these support continuous compliance requirements. Here's an example of Azure Security Center's regulatory compliance dashboard. And you see there's Azure Center for Internet Security benchmarks, there's PCI DSS 3.2 and ISO 27001. Now, with a little bit of information that we pre-based this session with, you might already know that if there's a security solution in the cloud that is claiming that they're going to show you compliance requirements according to PCI DSS, then there should already be a warning that you need to find out exactly which of those compliance requirements that Azure Security Center supports with respect to ISO 27001 and PCI DSS or Azure CIS benchmarks, because some of the documentations and the processes and practices as described by these compliance standards can't be automated. So you got to find your other organizational ways of dealing with those regulatory compliance requirements. Wherever tooling supports, well, that should be our first way to go. Here's also an example from the way Nessus allows you to scan specifically for PCI DSS. And you see in the screenshot, they're specifically talking about PCI DSS 11.2.1 and 11.2.3. So using this particular scanning template, you're going to satisfy a technical control that is mentioned in PCI 11.2.1. That is scanning for ongoing vulnerability management programs. And at the bottom of the screen, that's an example from continuous compliance, again from Tenable Nessus security platform. But the moving trend is compliance as code. We have seen a screenshot before that spoke that Telnet should be disabled according to the CentOS Linux security benchmark from Center for Internet Security. Well, how do you write that as code? In InSpec, which is one of the leading tools from Chef is the infrastructure as code provider, and they also have this great tool called InSpec that they tie with a lot of their programs. InSpec is open source, and in InSpec, you really describe that a package called telnet should not be installed. It is as simple as that, and you can execute that test in one line, and the test will tell you whether it passed on a certain system or not. You could run this test on your local machine, on your development environment, on your continuous integration server against a Windows, a Linux, or a Docker image, or a virtual machine of any sort. All of them are supported out of the box. How does this help us with a compliance requirement? If it is not clear yet, the example here is about inetd and xinetd not being installed on a certain target computer. The description there says that it comes from Red Hat Linux 5 Guide, i7.3.1 PDF, and that is the compliance requirement that this specific test is trying to solve. So if you are writing your own test, such as a certain package should not be installed, or a certain file should be present at a certain location, or a certain file should have certain directory permissions, and if that comes from your own compliance requirement, then this is a place where you can reference all of those. And in one run, you exactly know which compliance requirements you are failing against because you have traceability to your compliancy requirements here. Remember, we spoke about this ISO 27001 control that users shall only be provided with access to the network and services that they're specifically authorized to use. When we translate this to a Linux computer, in our work environment with respect to the Center for Internet Security Benchmark, when you translate that to a Windows computer with respect to the Center for Internet Security Benchmark, you can tag the highlighted controls there, such as anonymous access for Windows shares is disabled, encryption is forced for a Windows network password. All of these can be tied to that one compliance requirement of user shall only be provided with access to network and services they're specifically authorized to use. And this is a way Compliance as Code and the Center for Internet Security Benchmarks together help us solve the problem of translating the high-level ISO PCI or regulatory requirements to low-level technical fine-grained security controls and later implementing them as code so they can be run as often as they can. So what we want to do is show a demonstration of a sample compliance as code run on a target machine to comply to a certain standard. The standard we're going to talk about here is the Center for Internet Security Windows Baseline Level 1 standard. And the target system is going to be localhost because we didn't want to take any chances during this demonstration, especially on a recorded session. We have pre-recorded the demonstration just a couple of hours ago before the webinar, before the session. And here we are, the demonstration of compliance as code through an open source tool called InSpec.
So here is an example of Windows baseline inspect profile, and profile is a bunch of tests that can be run on any system. There are two interesting files here. One is control and other is inspect.yaml. Let's navigate to control. Control consists of these small Ruby files, which consist of set of policies that can be tested against any system. For instance, if you open rdp config.sh, we see a set of policies that are prescribed by Center of Internet Security, like password should be enabled for Windows Remote Desktop, and strong encryption of Windows Remote Desktop is required. And if you navigate further and look at access config, it also has tests for something like NTLM authentication, encryption, and Windows network session, etc. So those are individual tests that can be run against any system. So if you want to run this set of tests, then you go to Windows baseline directory and type inspect execute. Now what happens is inspect execute would run all the tests against your system and report failed and passed tests. For instance, there are 16 passed tests and few of the failed tests. So if you go to a policy that should have a minimum password length of 14, but this particular system had minimum password length of 8. So in this case, this particular policy has failed, and inspect has given you an alert that this particular policy is failed. So inspect is a very good tool that can run in couple of seconds, and it provides you with the result which are the failed and passed test cases when it comes to the compliance requirements.
Yeah, and compliance as code is really something that you can plug into your continuous integration pipelines, because when you compare this to tools such as Azure Security Center and tools such as Tenable, Nessus, continuous compliances, this is something that you could run on your continuous integration pipelines because it's very fast and it gives you instant feedback on the system that you just tried to build using your infrastructure as code solutions. So some of the advantages are they're very fast when it comes to when compared to traditional vulnerability scanning, and you can run them when required, like we said, during the build or after deployment or even continuously. And normally the kind of things that you want to check for or no changes are allowed to services or no changes are allowed to a system inventory. You can also check for whether a certain port or a protocol is enabled, such as HTTP should be disabled and then RDP should be disabled. You can check for all those nice things there. And when your infrastructure changes over a period of time, such as the one in the Honda example that we saw, when there's a change in your infrastructure, then you can also check for your infrastructure drift. How has the infrastructure drifted when compared to your baseline? That is also something that you could do with compliance as code with tools like inspect or open policy agents. And we're almost at the end of the session here. What we want to conclude is we often hear we're from a security background. You know, for the past couple of years, 4 to 5 years, we're mostly focusing ourselves on security, and we work with a lot of other security folks as well who think that DevOps is a security nightmare. And what we would like to say, it's not a security nightmare. It is a security opportunity when used right, when played well. And you got to focus on automating away your mundane, repetitive tasks, and some of the things that we have shown in this demonstration or presentation could be of use there. And you got to use your build pipelines wisely. Wisely should be an underlined word here, because we also see a lot of teams using compliance and security requirements. They just put them in the build, and then it just sits there doing nothing. Reports are sent over the email. Nobody looks at it. So you got to use your build pipelines wisely, with all the intention of failing faster. What we wanted to leave you with today is compliancy is an evolving field in comparison to DevSecOps. So as DevSecOps evolves, compliance requirements also evolve. And the requirements of compliance when it comes to application and operations are very different. And as a compliance officer or a chief security officer, you're going to have to work with two different worlds, two different set of security tooling, two different set of vulnerability management tooling to bring all of them under one space. So collaboration is the key. And we chose this cactus image for a reason. Even though compliance requirements can be tricky at the beginning, sometimes the flowers from cactus are the most prettiest of all.